Validation testing follows integration testing. The distinction between conventional and object-oriented software disappears and focuses on user-visible actions and user-recognizable output from the system. Validation test criteria: 1. Demonstrates conformity with requirement. 2. Designed to ensure that all functional requirements are satisfied, all behavioral characteristics are achieved, all performance requirements are attained. 3. Documentation is correct. 4. Usability and other requirements are met, e.g., transportability, compatibility, error recovery, maintainability. 5. After each validation test, the function or performance characteristic conforms to specification and is accepted. A deviation from specification is uncovered and a deficiency list is created. Configuration review. The intent of this review is to ensure that all elements of the software configuration have been properly developed, are cataloged, and have the necessary detail to bolster the support activities. Alpha and beta testing. Alpha testing conducted at the developer's site by end-user. Software is used in a natural setting with developers watching intently. Testing is conducted in a controlled environment. Beta testing conducted at end-user sites. Developer is generally not present. It serves as a live application of the software in an environment that cannot be controlled. Developer. The end user records all problems that are encountered and reports these to the developers at regular intervals. After beta testing is complete, software engineers make software modifications and prepare for release of the software product to the entire customer base. System testing. Software may be part of a larger system. This often leads to finger-pointing by other system dev teams. Finger-pointing defense: 1. Design error handling paths that test external information. 2. Conduct a series of tests that simulate bad data. 3. Record the results of tests to use as evidence. Types of system testing. Recovery testing: how well and quickly does the system recover from faults? Security testing: verify that protection mechanisms built into the system will protect from unauthorized access, hackers, disgruntled employees, fraudsters. Stress testing: abnormal load on the system. Performance testing: investigate the runtime performance within the context of an integrated system. Debugging __ is not testing, but often occurs as a consequence of testing. The debugging process begins with the execution of a test case. Results are assessed and a lack of correspondence between expected and actual performance is encountered. In many cases, the non-corresponding data are a symptom of an underlying cause as yet hidden. The debugging process attempts to match symptom with cause, thereby leading to error correction. The debugging process will usually have one of two outcomes. 1. The cause will be found and corrected. 2. Cause will not be found. In the latter case, the person performing debugging may suspect a cause. Design a test case to help validate that suspicion and work toward error correction in an iterative fashion. Software testing fundamentals. The goal of testing is to find errors, and a good test is one that has a high probability of finding an error. Therefore, you should design and implement a computer-based system or a product with testability in mind. At the same time, the tests themselves must exhibit a set of characteristics that achieve the goal of finding the most errors with a minimum of effort. Testability. Software testability is simply how easily a computer program can be tested. The following characteristics lead to testable software. -1. Operability. The better it works, the more efficiently it can be tested. If a system is designed and implemented with quality in mind, relatively few bugs will block the execution of tests, allowing testing to progress without fits and starts. -2. Observability. What you see is what you test. Inputs provided as part of testing produce distinct outputs. System states and variables are visible or queryable during execution. Incorrect output is easily identified. Internal errors are automatically detected and reported. Source code is accessible. -3. Controllability. The better we can control the software, the more the testing can be automated and optimized. All possible outputs can be generated through some combination of input and I/O formats are consistent and structured. All code is executable through some combination of input, software and hardware states, and variables can be controlled directly by the test engineer. The following characteristics lead to testable software. For decomposability, by controlling the scope of testing, we can more quickly isolate problems and perform smarter retesting. The software system is built from independent modules that can be tested independently. 5. Simplicity. The less there is to test, the more quickly we can test it. The program should exhibit functional simplicity. For example, the feature set is the minimum necessary to meet requirements. Structural simplicity, e.g., architecture is modularized to limit the propagation of faults, and code simplicity. For example, a coding standard is adopted for ease of inspection and maintenance. 6. Stability. The fewer the changes, the fewer the disruptions to testing. Changes to the software are infrequent, controlled when they do occur, and do not invalidate existing tests. The software recovers well from failures. 7. Understandability. The more information we have, the smarter we will test. The architectural design and the dependencies between internal, external, and shared components are well understood. Technical documentation is instantly accessible, well organized, specific and detailed, and accurate. Changes to the design are communicated to testers.